Okay, yesterday we did the name-based classifier, and that was based on statistics method. That's called, we call it a statistical classifier. Okay. Now today we'll discuss one another algorithm which is called the decision tree classifiers. And decision tree classifiers are quite good. And of course, it is time taking if you are going to take a big database consisting of, say, few hundreds of parameters. Okay, when I speak about parameters, I mean to say the attributes. Okay, and therefore this is having a problem. That means it is highly, we can say that it is very difficult to get the best decision tree. Okay. But we can always try to get an algorithm which is reasonably good. Okay. Now we start from the very beginning. Okay, now today we'll discuss the decision tree classifiers. Already I have discussed the basic concepts of decision tree. Therefore, I'll directly come to the actual one of the data set which is having 10 number of tuples where there are three particular attributes. One is the refund, second is the marital status, and the third is the taxable income. And the classifying attribute is the cheat. That means I want to find it out with what if I know the refund status, if I know the marital status, and if I know the taxable income. Is it possible for me to classify a particular person whether he or she is doing a tax evasion or he cheating tax? Okay. Now, when I am going to use this, what happens is that you are going to apply the algorithm on, say, one of the areas which is maybe on 2011 and try to predict on another area, which is in 2012. Now, in this case, we can apply one of the algorithm on 2011 in year 2011, and you can apply this algorithm in 2012. Okay. Now, if I have a data which is having a refund status as no and the marital status as married and the taxable income as, say, 80,000, what should be the output? Okay. Of course, it's a binary classifier. Therefore, the only output can be either a yes or a no. Okay. Therefore, in that case, you will only end up in having any two of the options which are there. Okay. That means the whole problem will come to the problem of classifying the data set into either cheaters or non-cheaters. Okay. Now, this we already did in the last class. Therefore, whenever we are having a data set, we have to try to find it out what is the type of the data into that. Therefore, it could be a categorical data where you can have a, say, yes, no, or it could be a nominal attribute where we can have different types of values which a particular attribute can take. And therefore, but it could also be a continuous attribute. A continuous attribute means it can take any value. Now, whenever you are trying to use a continuous value as for classification, there is a problem that every data can be unique. Okay, for example, the income of a person might be 1000K, 110K, say 120K, 95K, 80K, and therefore each and every data will end up in creating a pure partition. Okay, now try to catch my word which I say the pure. The pure means that each and every data in that particular attribute will be having unique values, and therefore it will be little difficult for us to classify that. Therefore, we have to make sure that how we are going to address those continuous values. Okay, now we will discuss this also, that how we are going to discuss these continuous values over here. If I am going to use this value, I have to also make sure that how you are going to handle this continuous value. Okay, so these continuous values might create a problem. Okay. Now, whenever you are applying classification, the target function is known, which is called that, which is the f, and then we are going to use a descriptive modeling and predictive modeling. Therefore, we can perform a descriptive modeling or a predictive modeling. Whenever we are trying to do a descriptive modeling, it means that we are having we are using an exploratory tool to distinguish between objects of different classes. Okay. For example, we want to understand why people cheat on their taxes. Whereas in predictive modeling, we can predict a class of a previously unseen record. Okay. Therefore, we are trying to perform a predictive modeling. Correct? Okay. Now, this we already did in also, but let me repeat once more. For example, what are the different types of classification tasks you can do? Now, also this is another problem which you can take as a project. You are going to predict a tumor cells as benign or malignant. You can classify credit card transactions as legitimate or fraudulent. That means whether the credit card transactions are legitimate or fraudulent transactions, which are fraud transactions. You can categorize news stories as finance, whether entertainment, or sports, or any particular thing. Now you can also identify emails as spam or spam emails or spam web pages or adult contents or any of the things which you find is relevant for classifying a web page or a spam. Now already spam email classification is a very, very good problem where you have to treat a particular email as a spam or a non-spam, and you know that even when you use a Gmail, it is also having a classification that you can mark it as a spam, and you must have seen over there that when you get a particular email, you can mark those emails as spam emails, and the next time the Gmail will try to learn from that and will try to classify such type of emails as spam emails. Okay. Okay. Now also you can also try to understand if a web query has some commercial intent or not. That means whether the web query which has been generated is from a commercial angle or not. Now these are the problems which are basically for problems of classification tasks. Now this you know that when we are going to have a training set, it consists of record in known class levels, and we are using the training set to build a classification model. Okay. A label tested is previously unseen data, which we used to evaluate the quality of the model. Okay. And the classification model is always applied to new records. Because already I told you yesterday that if you are going to apply with the known records, therefore it is not going to perform, and the model will overfit. Okay. Now let us try to understand how it works. You are having a training set and a test set. You are having say 10 data as a training set and say 5 data as a test set, and you are creating a model. When you create a model, you apply some learning algorithms. Now the learning algorithm as you apply could be any one of the learning algorithms, and you generate a model, and then you apply the model on some test set, and then you try to deduce. Now here, when you find that these are all question marks, this has to be filled with any one of them, the values from yes or no. That means you are going to fill it from any value from yes or no, and therefore this is how you are going to apply the model. Now, how we are going to evaluate the classification model? Already you are going to make a confusion matrix. The confusion matrix will be in a square matrix, which will contain the number of different classes. That will be n into n matrix, where n is the number of different class levels. Now, in this case, if you are having 2 class levels, it will be a 2 into 2 matrix. If you are having say 4 classes, it will be a 4 into 4 matrix. And those points which are given in blue, these values which are given in blue are all true cases, and these cases are all true cases. Whereas the one which is given over here, this one, are all false cases. That means whenever I want to reduce the value of F10 and F01 and try to increase the value of F11 and F00. That means when the actual output of a good model is that to maximize the F00 and F11. Okay, that means those blue ones are the ones which are classified correctly, whereas the one which is given the red are classified wrongly. Okay. Now in that case, the accuracy is nothing but the total number of correct predictions, but total number of predictions, and therefore it will be nothing but F11 plus F00 divided by all. Okay, that means F00 plus F11 plus F01 plus F10. So as and when the confusion matrix will become 3 into 3, the numerator will become F00 plus F11 plus F22 plus F33 plus F44 dash 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 to Fnn. Therefore, in that case, this value will keep on the numerator will always have these two values as same. That means it will be F11, F00, F22, and so on. Whereas in the denominator, you will have everything. Now that is called the accuracy. Now, if you are going to find the reverse, that means the error rate, obviously the wrong predictions will come up. Therefore, the values which are in the red will come on the numerator, and the values which are the all values will come in the denominator. That means my aim is to increase this accuracy, maximize it, as well as to minimize the error rate. Of course, we are going to maximize the accuracy, and if I do it, the error rate will automatically come down. Therefore, it's the same story. If I maximize accuracy, the error rate will come down, and if I minimize the accuracy, the error rate will go. That means these are totally inversely proportional. Okay, that's fine, because as and when the total number of data is, which is nothing but the denominator, if I increase one value, the other value will always be less. Correct? Now, what are the different classification techniques? One is addition tree classifiers, and there are few methods for this. Then there are rule-based techniques. Then there is a memory-based methods. Then you already know you have neural networks. Neural networks are also one of the very good classification methods. Then you have a naive-based and a Bayesian belief network. We already discussed yesterday the naive-based classifiers and the Bayesian belief. We'll do it in the next, say after 2-3 classes. Where already I told you the naive-based is having a conditional class independence, whereas the Bayesian belief will have a conditional class dependencies. Okay, and one of the most important algorithm which is having a support vector machines, which is also a classification techniques where we are using a support vectors to classify, and we are going to make a plane which is a linear plane which is going to separate all those points which are falling in one side of that plane with the other side of the plane. Therefore, if I have a linear support vector machine, it will have a single plane which will separate both these points. And we'll discuss all of them methods over here. Therefore, we will not be discussing neural networks and rule-based methods in details, but we'll try to give you a small idea about these methods. Of course, these are not to be discussed as from the algorithm point of view. We'll discuss because this you will already study in the next semester, where you will be having a soft computing techniques. Okay. Any questions till now? Okay. Now what's a decision tree? Decision tree is similar to a flowchart like tree structure. Obviously, it's not a binary tree. It could be a binary tree, but may not be a binary tree. Therefore, most of the time it could be a non-binary tree. Okay. Now, in a tree, there could be an internal node, there could be a branch, and there could be leaf nodes. There could be only three things, where the internal nodes are the nodes which test on an attribute. The branch represents an outcome of the test, and the leaf node represents the class labels. Therefore, whenever a flow chart will come, the internal nodes will test on an attribute. That means it will have a particular internal nodes will be there, which is going to test on an attribute. The branches will depict the outcome of that test. Therefore, in that case, it could be the branches can be 2, or can be more than 2 also. And the leaf node which will come will have one of the class labels. Therefore, in that case, it could be, say, if I am having only two of the class label, it could be only 2 of them, or it could be any number of. But the thing is that the leaf nodes which are there in the addition tree should have all the class labels what you are trying to classify. Okay, that means suppose if I am having a like this, I might have a tree like this, and I will have, say, like this. Then I will have something like this, where it could be something like this. Okay. Now this is the leaf node. These are all the leaf nodes, and therefore when I am going to do this, you are having all these leaf nodes are there. These are all leaf nodes. These are all leaf nodes. Whereas these are the internal nodes. These are the internal nodes. These are all the internal nodes. And the branches these are the branches. These are the branches. Okay, that means the outcome of a internal node are the branches, and therefore if I take that one, there are 3 branches. Therefore, obviously there could be at least 2 which will be there. Okay, fine. I think it's clear. Okay. Now let us take a addition tree like this. When I again come back to the old data set where you have 3 attributes. One is a categorical, the second is also categorical, third is continuous based. And I am trying to make a addition tree over there. Now here, if you see the addition tree which has been made, obviously there are only 3 attributes: refund, marital status, and taxable income. Now, out of those three of the attributes, one of the particular attribute will become the root. Now here, if you take, this is the root. This is the root. Now, why this has become the root? It depends on a concept what we call the information gain. We'll have that means in this case the refund, the marital status, or the taxable income, any one of the 3 could have become the root. But here, refund has become the root because it has the highest information gain. Now, how to calculate the information gain? We'll discuss in the next slides. But you have to understand that any one of them will become the root of the tree. And therefore, if I have a refund, obviously the output of the refund could be, there are only 2 of the possible outputs, yes or no. Now if I take over here, you find that these are all yes values. And there are 3 yes values and 7 no values. Therefore, in that case, this will have a 3 over here, and this will have a 7 over here. That means the split will be into 3 into 7. Now, you check the output of all the yes, and you check it over here. Okay, you check the output. And you find that all the 3 are no. It means that if the refund status is yes, cheating, there is no cheating. And therefore, this branch is a pure branch. It is having a 0 impurity. Okay, it is having a 0 impurity means anything what is coming from this branch are all pure partitions. Therefore, it is going to generate pure partitions. And therefore, there is no need to further classify it downwards because if I get a pure partition at that point, there is no need to further go down. And therefore, what I do is that I replace that with a leaf node having a no. But if it had not been a pure partition, I would have to further go down so that I will try to get a pure partition. The pure partition means if I apply some attribute, those values which are there in one of the sides should all be pure. Whereas in the other side it will be not pure. Okay. Now when I take refund is equal to yes, it generates a pure partition. But if I say the refund is equal to no, I find that here, if you are going to check with this one, you are going to just to check it out. There is a no over here. There is a no. Here also there is a no. There is yes. There is no. Yes. No. Yes. Therefore, you find that there are 3 yes and 4 no. Okay. Is it clear? There are 4 no's and 3 yes. And if I get that 3 yes and 4 no's, that means the partition is not pure. And therefore, I have to further build the tree. Now, I have already exhausted this attribute. And therefore, there are only 2 attributes which are remaining. One is the marital status and second is taxable income. Now, out of those 2, one of them will become the root. Now, obviously, which one will become the root will depend on the what? Which of them will become the root will depend on what criteria? Come on, anyone?
Sir, in the sense like...
For example, if I take 2 marital status and taxable income, one of them will become the root. This one, the yellow. If you see this yellow one, this one, you find that one of them will become the root of the subtree. Which of them will become the root of the subtree will decide on this criteria.
We see how most like what kind of like the division basically of elements, like the value division. Like if we are able to get at least one class label at any one value.
Correct. But what the word I used? I used a very important word.
Information gain, sir.
Good. It should be depend on information gain. That means I will calculate the information gain at that point. And if the information gain of marital status is more, then the information gain of taxable income, marital status will become the root, or vice versa. Now, how will I calculate? We'll just come to that calculation. But I mean to say that if I have the marital status, if I find that marital status becomes the root, it is because it must have a higher information gain than taxable income. Okay. So please keep on answering the question because I'm maintaining all the people who are giving the answer. I am noting it down. Salman Sheikh has given this answer, and Mohammad Abdul Basit has been giving the answers from. Therefore, just because these are all internal marks, will be calculated for internal marks. Okay. Therefore, just keep on answering the question. From next class, I will be putting one question in between, and you have to give an answer at that moment only in order to get attendance. It's not that you are just giving attendance just because of the fact that you are in the class. You have to give that answer in order to give out the answer to that. Whether it's wrong or right doesn't make a difference at that moment, but everyone must give the answer to that question. Okay? You be prepared from tomorrow onwards. Now, when I have a marital status, suppose marital status has become the root. Now you check what are different types of thing. Therefore, you see that there are 3 possible outputs. One, it is single, or married, or divorced. Okay. Now you check the single ones. You check the single. This one, single. Now this is single, and this is single, and this is single. There are 4 singles. Now check whether these are pure partitions or no or not. Single, okay, you find that there are 2 no and 2 yes. Okay. Now you check for married. You check for married. Okay, let me see. Now you are going to check for married. See, married is this one. Now you check for this one. Now check. What did you get?
It's a pure partition.
Same class K pure, sir.
That means all 4 are having the same output. That means that generates a pure partition. All 4 are no. Therefore, there is no need to go further, because if you go further also down that, you will always get a no only. And therefore, what I am going to do, I am going to replace this by no. I am going to replace this by no, because this is going to generate a pure partition. But if I take single and divorced, it is not going to give a pure partition. And you can very well see over here that when I am going to do like this, it is not going to generate a pure partition. Now let us try to just check it out. Okay. Now you are going to check with this. Now you see for married. Sorry, divorce. This is yes. This is no. And therefore, it is not going to generate a pure partition, because you see that for married it is always no. For single it is no and yes both. For divorce also it is no, yes both. Therefore, you cannot get a pure partition in the left side. Therefore, you have to again try to partition it over from here. And you know that you are only having one of the attributes which is left. You already used refund, you already used marital status, and therefore now what remains is only taxable income. Therefore, there is no need to calculate the information gain. And therefore, that becomes the root automatically. But if there would have been more than one of the attributes over there, you have to calculate the information gain in order to find the one which will come over here. You have to use the information gain to find what will come over here. But here you are not going to do, because you are getting it. There is only one of the attributes which are left. Okay. Therefore, what you are going to now, here is the catch, and here you have to check it very well. Now you find that taxable income are all continuous valued, and if you are going to check with that, you will find that how many different values are there. You see 125k, 100k, 70k, 120k. Each one of them are having different values. So what will happen? You will get 10 different branches, isn't it? Now try to understand this very well. If I am using the taxable income over here, these are all different values. And therefore, there will be 10 different branches over here like this. You will have all these 10 branches, where each one will generate a pure partition, isn't it? Each one of them will generate a pure partition, which will not solve the purpose. Why? Because if every partition is pure, in that case, if I am having say 10,000 records, there could be say thousands of taxable incomes, and therefore I will generate thousands of branches. Therefore, this problem cannot be solved like this. Therefore, what you have to do at this point, you have to find the split point. You have to find the split point, and the split point is the point at which you are trying to use this particular continuous value to find the best split point. Okay. Therefore, I am going to find the split point. And which are the split point I will try to find? Of course, I will try to find the best split point. I will try to find the best split point. Now, the best split point will be, there is a method to find this, and let us try to understand at this moment that I find that 80K is the best split point. Okay, let us try to use that. By some method, I found that 80K is the best split point. And therefore, whatever which is less than 80K will fall in one side, and what is more than 80K will go in the other side. Now, which are the one which are less than 80K? This one and this one. The 3 one. And you check the corresponding over here. What did you get? What did you get over here?
सर इसमें आप मेरिट को क्यों कंसीडर कर रहे हैं? वो तो पहले से ही हमने ब्रांच सेलेक्ट कर दी है.
I'm not getting. फिर से बोलो क्या बोले?
सर आप इसमें जिस अंडर 80K कह रहे हैं सर इनकम, तो उसमें आप सिंगल भी ले रहे हैं, मेरिट भी काउंट कर रहे हैं, जबकि अपने मेरिट को तो पहले ही ब्रांच सेलेक्ट कर दी.
ठीक है, that is fine. बट जब उस जगह पे आया तो वो रिफंड और मैटर स्टेटस को लेकर सब ब्रांच पे आया ना. देखो मुझे उससे मतलब नहीं है. अगर उस एट्रीब्यूट पे अगर होना है पार्टीशन तो ऊपर हो चुका है. जो थर्ड जगह पे यहाँ जो टैक्सेबल इनकम पे जब पहुंचा तो ऑब्वियसली कौन से रिकॉर्ड आएंगे जिनका रिफंड स्टेटस नो होगा और जिनका मैटर स्टेटस चाहे सिंगल होगा चाहे डाइवोर्स होगा. यही होगा ना. बिकॉज टैक्सेबल इनकम पे आने के लिए तुमने इस पाथ से आए हो. इस पाथ पे कौन आएगा? जिसका रिफंड नो हुआ है या जिसका टैक्सेबल सिंगल या डाइवोर्स है उसका मैटर स्टेटस. ठीक है. All the records which are lying in that one will be either having a refund status no or will be either a single or a divorced. Now,
तो सेकंड लास्ट में तो 75K वो मेरिट है सर.
75K.
सेकंड लास्ट सर.
ठीक है, let it be there, let it be. But I'm just trying to. You are correct. जो तुम बोल रहे हो समझ गए कि मैटर स्टेटस 75K तो राइट में आना चाहिए था. Correct, let it be there. बट अगर हम लोग मान लो सिंगल या डाइवोर्स ही देखते, चलो ठीक है. इफ आई जस्ट आई विल ट्राई टू एक्सप्लेन दैट. ओके, दिस व्हाट आई हैव. नाउ इट्स फाइन. देखो इन दैट केस चलो इसको हटा देते, ये भी मैरिड है. अब सिंगल में कौन बचा तुम्हारा? ये बचा. इज ओनली वन ऑफ देम, है ना. ये बचा दिस वन. देयरफॉर लेस देन 80K का हमारा आउटपुट क्या है? नो. It means it is going to generate a what? Pure partition. It is going to generate a pure partition. And therefore, less than 80K will generate a pure partition. Isn't it? That means those person who are having a refund status no, who are single or divorced and having an income less than 80K are cheaters. Okay, it's an example. Don't take it otherwise. Okay, that means it's an 80K. And now let us say the yes cases. If I take the yes cases, that means those of them which are having greater than 80K income and who are a single and you check it over there. Therefore इसमें जो तुम बताया, now let us try to understand it. तुमने ठीक इसको हटा दो बिकॉज ये तो तुम्हारा ये है. इसको रिमूव कर दो बिकॉज ये तुम्हारा यस था. ये भी रिमूव कर दो, यस था. ये भी रिमूव करो, यस था. तीनों को रिमूव कर दो. अब 80K से ऊपर का देखो. ये देखो नो. ये देखो एंड सॉरी इसको भी मत देखो बिकॉज ये वैलिड था. Then you don't see this one also. ये खत्म हो गया, मेरिट था. ये भी होता है. Now कितने बचे? Only 3 records. That means whose refund is no and whose marital status is either single or divorced. Therefore इसमें कौन बचा? ये बचा 1, this 2 and this 3. Fine. Did you see how it is removed? I चूंकि इस ब्रांच में कब आया है जब रिफंड स्टेटस नो है, तो ऑब्वियसली यस वाला हटा गया आपने। ये हट गया, ये हट गया यस वाले, ये हट गया, ये हट गया यस वाला, ये हट गया यस वाला। Then I remove those who are married because that is coming in the next branch. Therefore, in that case also, yeah, this is gone, and this is gone. Now, I will also remove those which are less than 80K because that is coming in the left branch. देखो ये भी खत्म। Now what remains? You already removed 7 of them. This one also married. And therefore, what you find that I am only having these 3. This one, and this one. And these 3 are all yes. It means it is generating a pure partition on the right hand side also. And therefore, it is the tree will now have the leaf node as a yes. Is it clear? Okay. Now, if this is there, it is also possible that after this, it may not lead to a pure partition. जैसे कि मान लो यहाँ पे yes के बदले लास्ट वाले में मान लो यहाँ पे होता तुम्हारा no, मान लो यहाँ पे होता, यहाँ पे no होता, यहाँ पे no होता, यहाँ पे, then it would have not led to a pure partition. But you cannot do anything because all the attributes has been exhausted, and after that also you will not get a pure partition. Clear? यहाँ पे तो ऐसा हो गया, but it might not be possible in many cases. ऐसा होगा नहीं कि all partitions pure मिलेगा, ऐसा नहीं होता है. It's just a case over here because तुमने attributes भी कम है और तुम्हारे data points सिर्फ 10 है. Therefore it is happening like this. But अगर ऐसा नहीं होता है, then you have to find that the stopping criterion. The stopping criterion. Just a moment. Okay, fine. Okay, now when I am going to say if the partitions are not pure at that moment, then what I should do? Therefore, there are 3. What you do is that you have to apply a majority voting. The majority voting means that if at this point if I have this point at this point, if I find that there are 2 yes and 1 no, then in that case, this is 2 is more than 1. Therefore, I apply yes at that point. And this is called the majority voting. It will only take place if the attributes are exhausted, and after that also you are not getting a pure partition. Is it clear to you?
सर इसमें इसमें मैरिड में भी प्योर मिल गया सर, हर बार थोड़ी ट्रू होगा।
करेक्ट, मैरिड
इसमें
में
क्या करें?
मिल गया तो हमने वहां पे इसको नो लगा दिया। सिमिलरली रिफंड में यस आया, वो भी प्योर मिल गया। मैरिटल स्टेटस के बाद हमने चेक किया टैक्सेबल इनकम पे, लेस देन 80K विल गिव्स a pure partition, greater than 80K also gives a pure partition, but that is just a chance because the number of tuples are very less. If you would have made it say 20 tuples, 30 tuples, 40 tuples, it would have not generated a pure partition. Therefore, what you have to do is that you apply a majority voting. Why will you apply majority voting? Because you do not have any more attributes to further partition it down. Therefore, what we are doing is that we are trying to do a recursive partitioning. We are trying to do a recursive partitioning. And we are stopping at when I find that therefore only there are three possible scenario where you have to stop further partitioning. Okay? Now understand it very well. There are basically only three possible scenarios where you have to stop the partitioning. One, all tuples in that branch belong to the same class. All tuples in the same branch belong to the same class. जैसे कि रिफंड के यस के साथ हुआ था या मैरिटल स्टेटस मेरिट के साथ हुआ था। सेकंड, कोई भी रिमेनिंग एट्रीब्यूट नहीं बचा, देयर इज नो रिमेनिंग एट्रीब्यूट and therefore you have to apply a majority voting. So this has not been here, but if I assume that this 10th record would have been no, if this 10th record would have been no, then it would have happened, because greater than 80K will not generate a pure partition because you find that there are 2 yes and 1 no. Are you getting it? Suppose if this would have been no, then you find that this is yes, and this is no, and therefore it is not generating a pure partition. But you cannot further come down because there are no attributes remaining, and therefore you have to stop at that point. And the third one, yeah, any questions?
So my question is, suppose refund में एक या नो की जगह एक यस कर दें, तो वहां पे भी हमें लेफ्ट हैंड राइट पे ट्री बनाना पड़ेगा ना?
बिल्कुल सही बात, परफेक्ट अभिषेक. If you will do like this, obviously if it not going to generate a pure partition, you have to further make it down. अब अगर मान लो ये नहीं होता, यहाँ पे नहीं होता, तो क्या बनता यहाँ पे? अगेन तुम इस पे करते, स्प्लिट करते इन्हीं में से किसी पे, यानी this could have been either marital status or taxable income depending on the which is having the higher gain. Correct, it is there. You have to build the tree in such a way that our aim is to get a pure partition, but it is not always possible. If there would have been lot of attributes, it would have been possible. But since the number of attributes are quite less, it may not generate a pure partition. Sorry, since the number of attributes are very, very less, it will always generate, most of the time generate a pure partition only. And if also the number of tuples are very less, therefore obviously it will generate a pure partition. So दो part हो गया, when all the tuples belong to the same partition, stop. If there are no remaining attributes, you have to apply majority voting and stop. And the third is that there are no more tuples to do. There are no more tuples, and all the tuples are exhausted. And therefore, what you will do is that you will get an empty partition at some place. And therefore, what you have to do is that you have to make a leaf with a majority class. For example, तुमने टैक्सेबल इनकम पे किया होता और सारे वैल्यूज जो है एक ही साइड में आ जाते, तो क्या होता? At that point of time, you could have used it like this, that value will come in the one side. Just a moment, please. Okay, fine. That means if there are no tuples for the given branch, that means that will create an empty tree, and therefore in this case you are going to make a leaf node with a majority class. Now this algorithm is recursive. Why I mean to say recursive? Because at every level you apply the same methods to do that. Now let us come to the complexity of the algorithm. The complexity of algorithm is given by order of n into d into log of t. And this is the complexity of the algorithm. Order of n into log d into log of d, where n is the number of attributes. Okay, which are number of attributes. In this case, it is 3, and d is the number of training tuples in the database. That means d is the number of tuples. Therefore, in this case, it is nothing but 3 into 10 into log of 10, which will be something around 3. Log of 10 of base 2 will become a 3. Therefore, यहाँ पे it is going to be like this. Therefore, this is the order of the big O notation complexity of this algorithm, n into d into log of d. Any questions? Now we'll discuss this problem. We'll take the problem which is given in this one, and we'll try to show you how the information gain works. Now this is the tree, but from here I get like this. Okay. Now this could be another tree. Now here you find that refund is generating at the top, and you get a tree like this. But if it is not like this, it could also make a tree like this, where the metal status would have been the root, and if I say married, it generates a pure partition. Then I have a singular divorce, and there I will have check if it is refund. If it is yes, this is generating a pure partition, and then keep on going like this. Therefore, there could be many different trees, and all of them are addition trees. Correct? All of them are addition trees. But the one what we will make based on information gain will be the actual addition tree. Therefore, at this moment, I did not talk about information gain. I was just trying to make sure that you can generate many different addition trees from the same data set. And if, for example, I can also make the taxable income at the root and try to do like this. But whatever you are trying to generate, it will stop at a leaf which normally will be pure. But if it is not pure, you apply any of the stopping criterion and stop at that moment. Any questions? Therefore, tomorrow I will discuss the information gain theory, and therefore try to have, there are basically two things which we discuss. One is called the gain, and second is called, therefore the algorithms which are there are having 2-3 different type of parameters. One is information gain, one is called the Gini index, and therefore there is a split info. Therefore, there are a lot of concepts over here. You can apply to this algorithm is applied in addition tree algorithm. I told you yesterday it is called the ID3 algorithm, and also called there is another algorithm, the C4.5, and these two algorithms are all addition tree classifier methods. Therefore, we'll discuss the algorithm tomorrow. Any questions you would like to ask? May please.